recording. Okay, so I'm going to go over the test first, the 6B test. I believe some of you already have it back. Some may not. I'm going to minimize this right here. And again, if you have questions, feel free to speak your microphone or type in the chat. Really quickly for this problem, it's obviously shifting 1 left and 3 down. So you're going to be starting it right at 1, -1, -3. And if you were to plug in 0, so you make a little table, obviously when I plug in -1, I get -3. If I plug in 0, you should get -1. And if I plug in 3, because the 3 plus 1 is 4, and I could square root that, that should get you 1. And there's your curve. So really simple. Or if you took the parent function, root x, and made a table for that, and then made an adjustment for the new table, that works also. 0, 1, 4, 0, 1, 2. And because we're shifting 1 left, you take 1 away from the x coordinates. And because we're multiplying by 2 and then subtracting 3 afterwards using PEMDAS, you can multiply y values by 2 over here, multiply 2, then subtract 3. You would get those new y coordinates. So that's how that graph is done. Domain should be pretty obvious. Should be x is greater than -1, greater than equal to -1. So you have to write it in interval notation like this. And range, the low point is -3 for y, and it goes up forever. So -3 to infinity with a bracket. If you didn't put brackets, I took out a half point. And we state the transformations. I haven't forced you guys to do it in the right order, but if you follow PEMDAS, the first thing x sees is the +1. And I didn't take out points in the wrong order because I haven't taught you guys that yet. But you do want to shift 1 left. You do want to vertically stretch. If you didn't say vertical stretch, I did take off a half point. You have to say vertically stretch because stretching could mean a lot of different things. It could also mean horizontal stretch. So you have to be very explicit. Vertically stretch by a factor of 2. And then lastly, shift 3 down. That's how you have to say it. So that's number 1. Number 2, we do have more shifting happening here. So cube root of x looks like this. So if you make a little table for that, -1, -1, 0, 0, 1, 1, and so forth. So you have this, this, and this. The graph will look like this, right? But that's not what we're trying to do here. We're trying to shift it. So you got to go 2 right. So I'm going to go 1, 2, 3. And then you have to multiply by -1. And add 1. So what's going to happen is that you're going to have then, if I plug 1 in, I get 0. Was that right? Hold on. 1. Oh, sorry, I get 2. My bad. So multiply by -1, add 1. Multiply by -1, add 1, you get 1. Multiply by -1 and add 1, you get 0. There we go. And it does reverse because of the negative out in front of the radical. So you have 1, 2, 2, 1, 3, 0. And I did it wrong. Hold on. 1, 2, 2, 1, 3, 0. So the graph will look kind of like this. Domain range will always be all real for cube root functions because you can cube root whatever you want, and the y values are all covered. And the shifting, you're going to obviously shift 2 right. And we do reflect first, because if you were to shift up 1, then reflect, actually you'd have the wrong graph. And this will all get reinforced in pre-calculus, but reflect about the x-axis. It does flip over about the x-axis when you compare it to the parent function, which is cube root of x. And of course, shift 1 up. And again, for those who took the test in the AOC, I do have your exams. I'll hand it back to you on Friday. If you would like to actually see what you missed, just ask, and I'll more than happy to take a picture with my phone and email it to you. Or have a scanner on my phone, so I can do that too. But all the grades should be in Schoology. So that's all of number 2. Number 3, when you find the inverse, what you need to do is you need to switch x and y. So f of x is y. So you get 2 over y plus 1. X minus 1 equals 2 over y. Multiply both sides by y. And lastly, divide both sides by x minus 1. And the way I divide the points, 1 point for doing that, 1 point for doing that, 1 point for doing that, and 1 point for doing that. I did ask you to label as g of x. So you make sure you put g of x there, just so it's easy to do parts B and C. So then you're asked to find g of fx. So a little different than the reviewed problems. I had it as f of g of x. So the same thing, you'll still get the same result. So if I do g of f of x, I'm doing 2 over, and I replace x here with f of x, which is 2 over x. Let's switch colors. 2 over x plus 1, and I bring back the minus 1 that was over here. So really what's happening is that what I'm highlighting in orange gets replaced with all that right there. So you simply take out the x from g of x and replace it 2 over x plus 1, which is f of x. When you clean it up, you should clean it up very, very nicely. Should clean it very nicely. The ones cancel here. And this is where you got to be well versed with your fractions. The 2 up top is like 2 over 1, and of course you have 2 over x in the bottom. It's a division problem, so you flip the bottom fraction. The 2's cancel, and you get straight up x. That's all. So that should happen. And then C, I chose a crazy number because if you get x, then the answer is 0.257. Because the answer for part B was, g of f of x was x. And if you plug in 0.257, you replace x with 2.257. So that's all. You didn't have to, you could plug it into f if you wanted to, and then plug in the g, but that's a lot of work. Remember, it's only 1 point. I made it that simple. Then with the last page, this went well. You want to subtract the 2, so you have 2x minus 3. Overall, this went great. Much better than the previous one. Square both sides. X plus 6 equals 4x squared minus 12x plus 9. We were all terms of one side here. Not the easiest to factor, but if you do a little diamond thing, 4 times 3 is 12, negative 13. You get negative 1, negative 12. You can split the middle term. And then you just factor by grouping. You can factor out x, so you get 4x minus 1. Factor out negative 3, 4x minus 1. So it's x minus 3 and 4x minus 1. So the answers are 3 and 1/4. You do have to check the work. If you plug 3 in, you have 2 plus root 9 equals 6 minus 1. You get 5 equals 5. Bingo, that works. 1/4 is kind of a pain, but if you were to do that, you have 2 plus root, that'll be 25/4. The reason why is because 6 is 24 out of 4, plus 1/4 to get 25/4 equals 2 times 1/4, which is 1/2 minus 1. You get negative half, but here you get 2 plus 5/2, which is not the same as the other side. So yeah, so that's so 1/4 didn't work, but 3 did. And then lastly, this one here, you got to subtract the 1 and divide the 2. You subtract the 1, you get 32. Divide the 2, you get 16, of course. Then you have to raise both sides to the 3/4 power. But when doing that, that's actually going to involve a 4th root. So you're really 4th rooting, right? So that's plus or minus. Plus or minus, and then 4 through 16 is 2. You got to cube that, which of course is 8. So you have plus or minus 8 equals x minus 1. X equals 1 plus or minus 8. You get 9 or negative 7. And both will work if you throw it back in. Rarely, I don't think you'll have an issue if you cube root. I think you should be fine because you can cube root negative numbers. So 2, 9 minus 1 raised to the 4/3 plus 1, that's 2 times 8 to the 4/3. Cube root of 8 is 2 to the 4 power 16. Yeah, that works. If you plug in negative 7, you have negative 7 minus 1. Actually, the reason why both work is because you're even powering with the 4 in the numerator. So it's negative 8, cube root of negative 8 is negative 2, negative 2 to the 4 power 16. Yeah, that works also. So we've gone over the test. It's recorded. So if you ever like for final exams, this would be a good recording to watch. Try to maybe label it appropriately so you know to identify it. Maybe what I'll do is let me stop this record. So I'll say this is test review. And then I'll create the next one called 7.1, 7.2. So let me go and stop that recording right now.